Welcome dear students. Now we can see the chapter Trigonometric Functions of class 11 or first PUC. See, first we see the introduction part. The trigonometry is one of the oldest branches of mathematics, and trigonometry, as the name implies, is concerned with the measurement of the triangles. That means the trigonometric functions only applicable to the triangles. But which triangle? The right angle triangles only. This we have discussed in the class 10. A triangle has 6 elements, namely 3 angles and 3 sides. The measurement of the triangle means determining all the 6 elements of the triangle given sum of its elements. So these calculations can be confirmed or confined to right angled triangles because all other triangles can be divided into 2 right angled triangles by dropping an altitude from its vertex. Therefore, whenever we have a right angled triangle here or any other triangles, if we have a equilateral triangle, when we draw a altitude to from any one of the vertex to its opposite side, then it will be again we have a right angled triangle. Therefore, so the measurement of the triangle depends upon the study of the certain functions known as trigonometric functions. The 6 trigonometric functions you are already studied in the class 10th. They are sine, cosine, tangent, cosecant, secant and cotangent. The trigonometric functions are used to find the lengths that cannot be measured directly. So for example, the distance between the banks of the river, or the distance of the person and height of the poles and etc. There we can use the trigonometry. So trigonometric functions are used to find the length, and it cannot be measured directly. Surveyors use it to find the heights of the mountains and the position of the places by using this trigonometry. So engineers also use it in the design of the large structures of the buildings, and astronomers use it to accurate measurement of time and locating position of the places. But nowadays the trigonometric functions are used to represent ranges of values which are replaced again and again. They play a basic role in the theories of light, sound, radio, TV, etc. and generally in all phenomena of the vibratory characters. In business, and the phenomenon of business cycles can be explained by some of the trigonometric functions. So here mainly the mathematicians Euler and the Fourier, Gauss, John Bernoulli and de Moivre are some of the mathematicians who contributed to the development of the branches of mathematics. A sound knowledge of trigonometry is essential in every branches of higher mathematics, than that we discussed in the higher classes only. But here we see the basic fundamentals which are favored to the trigonometric functions. In that first one we can see the radian measurement of an angle. What is radian measurement? See, you are familiar with the constant pi. This we can use to convert the degree measurement into the radian measurement and radian measurement into the degree measurement. We can see here the word angle. First the important thing is the angle. What is angle? The word angle is commonly used with 3 different meanings, namely geometric angle or the arithmetic and algebraic. So what is geometric angle? An angle is a figure formed by 2 rays. When the 2 rays intersect, or any 2 lines intersect, or also when any 2 planes are intersect, through the point of intersection there is formation of one measurement, and that measurement can be measured by angles. That is called the angle. The angle is the forming there. Therefore, by 2 rays having the common initial point, here O is the initial point. 2 rays are OA and OB starting from the initial point O. The 2 rays are called, this OA and OB are called the sides of the angle, and the common initial point is called the vertex. This is called the vertex. So where the angle is forming? The angle is forming here. So, and it is represented by, in trigonometric functions, generally as theta. This is a theta. Therefore, angle AOB is theta here. What is the angle measurement? An angle in the arithmetic sense is a number that measures the sizes of the geometric angle. That is the size. What is the measurement? Sizes are there, 0 degree to infinity. So if the ray OA, here this is the ray OA, rotates about the point O. If we rotate this, we get a cone-like structure from the initial position OA to the terminal position of OB. If we rotate from OA to OB, then OA occupies the place of the OB and OB occupies OA, so that it is said to generate the angle AOB. Then here formation of the angle AOB. That is a rotation of 1 by 360th part of one complete rotation is how much degree? 360 degree. This we know from the geometry. So a rotation of 1 by 360th part of the complete rotation is called 1 degree. Here it is called 1 degree. Complete one rotation is 1 degree. 1 degree is what? 60 minutes. In our for a clock, if we compare it to the clock, then 1 degree means what? 60 minutes. That is the 1 hour. 1 hour is 1 degree we consider here, and that is 60. Each can be represented by 60 dash. 1 dash is 60 minutes it is. And 1 minute is equal to how much seconds? 60 seconds, and we represent this as a 60 double dash. That is 60 double dash means 60 seconds, and 60 single dash means it is a 60 minute. Next we see the radian measurement of an angle. We see the definition. A radian is the angle subtended at the center. Radian, see here, it is 1 radian. I represent 1 to the power c, means we can read this as 1 radian. If the power is c is written in this chapter trigonometry, it is 1 radian or any number, that is it's a radian. So a radian is the angle subtended at the center of a circle by an arc of length equal to the radius. Here see AB, this AB is the arc, OA is what? Radius. OB is what? Radius. But here the radius and the length of the arc are same. That is, if the radius is 5 units or 1 unit, AB, the length of the arc is also 1 unit. Hence we represent angle AOB is equal to 1 radian here. Angle AOB is 1 radian. That is equal to 1 to the power c, means 1 radian. If and only if the length of the arc is same as the length of the radius r. Now we can see the relation between the degree and the radian. What is degree? Degree we know how to write, that is 1 degree, 2 degree, 90 degree and so on. But how can we write radian? See here, the circumference of a circle of a radius 1 unit is 2 pi units. How is that 2 pi unit? The circumference is 2 pi r, but the radius is here equal to 1 unit. So 2 pi into 1, that is 2 pi units. Thus one complete revolution of the initial sides makes an angle of 2 pi radians. When it is 2 pi radians, when the radius equal to unit radius, then it is the complete revolutions of the initial sides makes an angle of 2 pi radians. But we know that in a degree measure this is 360 degree. One complete revolution is in degree measure, how much it is? 360 degree. In radian measure, how can we say? 2 pi. Therefore 2 pi and 360, they are same, but 360 is the degree measure and 2 pi is the radian measure. Thus 2 pi is equal to 360. 2 pi radian is equal to 360 degree means what is the value of the radian pi? That is, or pi is equal to here 360 divided by 2, that is 180 degree. Therefore pi radian is actually how much degree? 180 degree. That is pi radians is equal to 180 degree here. Now we note that 1 radian is equal to 2 by pi into 90. 1 radian is equal to 2 by pi into 90. This implies pi radian is equal to 180 degree. So 1 radian is equal to 90 into 2 is 180. 180 by pi, which is nearly equal to 180 into what is the value of pi? Is 22 by 7. When we take the reciprocal, it is 7 by 22. After multiplying or simplifying, we get 57 3 by 11 degree. Taking pi as 22 by 7 here, substituted already. And now 3 by 11 degree. Here 3 by 11 degree is there. This we convert into the minute or the second. That is 3 into 3 by 11. 1 degree is how much? 60 minute. That is 6 into 60, which is 16 4 by 11 minute. That is approximately 16 minutes and 22 seconds here. After simplifying we get, so 1 radian is approximately equal to here 57, this is 57 degree and 16 minute and 22 seconds. Also 1 degree is equal to pi by 180, that is approximately equal to 0.01746 radian in the constant value. Next we remember the following table giving the relation between radian measures and the degree measures. See here 15 degree can be written as 1 degree. See before that the pi radian is how much? 180 degree. How can we convert a degree into radian? For a given degree we have to multiply by pi by 180 degree. If you want to convert from radian into degree, then for a radian measurement you have to multiply by 180 by pi, then the given measurements can be converted into either radian measurement or degree measurement. Here it is in the degree measurement. Multiply this by pi by 180. Don't substitute pi is equal to 22 by 7 because it is in the radian measurement. Only you simplify 15 into pi by 180, you will get pi by 12, and 30 into pi by 180, so 0 0 cancel, 3 1s are 3 6 are 18, so pi by 6 you will get. 45 degrees pi by 4, 60 degrees pi by 3, 75 degrees 5 pi by 12, 120 degrees 2 pi by 3, and 135 is 3 pi by 4, 150 degrees 5 pi by 6, 180 degrees pi, and because already we have derived this, 180 degrees pi radian, 270 degrees 3 pi by 2 radian, and 360 degrees 2 pi radian, and 90 degrees pi by 2 radian. But you need not to by heart these values. So if you know this, how to convert from degree into radian and radian into degree, then you can easily convert the given degrees into radian or given radian into degrees. Now we see the example. The angles of a triangle are such that one is the average of the other two, and the greatest is twice the least. Express the angles in the radian measure. What is given here? The angles of a triangle are such that one angle is the average of the remaining two angles, and the greatest angle is twice the least. Express the angles in the radian measurement. See here, let the angles of a triangle be A, B, C, we say. Here C is the greatest angle, A is the least angle. Given that greatest angle is twice the least, therefore C is equal to 2A here. And also given that 1 is the average of the other, therefore the B is angle to B is average of A and C, or B is equal to A plus C divided by 2 we can write here. We know that sum of all the angles of a triangle is equal to 180 degree. In the pi radian it is pi. And we write A plus C plus B is equal to pi radian. We rewrite this. Then what is A plus C is 2B. Substitute here. 2B plus B is 3B is equal to pi radian. Hence B, angle B is equal to pi by 3 radian. Also A plus C is equal to 2 pi by 3. This implies what is A plus C is 3A. That is, since C is 2A, the greatest angle is twice the least angle. So here we substitute C is 2A. 2A plus A is 3A, that is equal to 2 pi by 3. Hence we have A is equal to here 2 pi by 9. 3 comes to here, multiplied by this 3. 3 3 is a 9. 2 pi by, and C is equal to, substitute here, we get the value as a 4 pi by 9 radian. Next question, find the acute angle in the radians between the minute and hours hands of a clock when the time is 4 hours 20 minutes. See here, the time is 4 hours 20 minutes means here the hour hand is at 4 and minute and in between 4 and 5 here. That is at 4 hours 20 minutes the minute hand is at 4 and the hour hand is at the hour hand is between 4 and 5 here. Therefore, the required angle is the angle turned by the hour hand in 20 minutes here, because the time is 4 hours 20 minutes. As the angle turned by the hour hand is 1 hour is 30 degree, because what is the complete one revolution is 360 degree. Here how many numbers are there? 12 are there. So 360 by 12, 12 ones are 12 30s are. Therefore 1 hour is equal to how much degree? 30 degree. Therefore the required angle is 20 minutes by 60. So 20 minutes means out of 60 into 30 degree. So we get it is equal to 10 degree. So 0 0 cancel, 3 1s are 3 2s are 2 1s are 2 10s are 10 degree. 10 degree convert into pi by radian, that is pi by 180. 0 0 getting cancelled, therefore it is pi by 18 radian. Next we can see the two standard results. See here, we know that equal arcs of a circle subtend equal angles at the center. This theorem you have studied in your high school sections, that is equal arcs of a circle subtend equal angles at the center. Equal arc of a sector or the circle subtend equal angles at the center. What is this? Consider an arc of length L here. We can say this arc of length L of a circle of radius r subtending an angle of theta here at the center. Also an arc of length r here, radius and the arc of length are same, subtend 1 radian at the center. Then the ratio L by theta equal angles subtend equal angle at the center. So L by theta is equal to r by 1. So L is equal to r into theta. This is known as the length of the sector. This formula is known as the length of the sector, and sometimes we use S is equal to R into theta. The second one we know that area of the equal sectors of a circle subtend equal angles at the center. Area of the equal sectors, if area of this sector of a circle subtend equal angles at the center. See, consider a sector of a circle of radius r having the central angle theta here. The full circle can also be taken as a sector of circle having the central angle 2 pi. Full circle, the radius, what is the angle of the circle? Complete angle, it is 360 degree. In the radian measurement, it is 2 pi radian. Therefore, the area of the sector divided by 3 is equal to area of the circle divided by 2 pi, comparing the ratios, so that we have area of the sector is equal to area of the circle divided by 2 pi and theta transposed here into theta, that is theta by 2 pi into area of the circle. What is the area of the circle? Pi r square. Here pi and pi getting cancelled, that is 1 by 2 r square theta. Therefore, the area of the sector of a circle is equal to half r square theta, and this is known as the formula. Next we see the problem. A horse moves in a circle at one end of the rope. Horse is moving like this. Here horse is ties and this is the rope. The horse is moving here, one end of the rope, and the rope of 10.5 feet long, the other end of the rope being fixed. How far does the horse move when the rope raises an angle of 150 degree? The angle formed here, horse coming starting from the, this is starting point, and the horse comes here. The angle formed here, it is 150 degree at the center. So given what? The radius is equal to 10.5 feet in the decimal form, or in the fraction form it is 21 by 2 feet. Theta given as 150 degree, convert it into the radian measurement by multiplying pi by 180. 150 into pi by 180, we get 5 pi by 6 radian. So what is the length of the arc? Length of the arc is the horse moved, the distance covered by the horse, that is S is equal to R into theta. R is 21 by 2, theta is 5 pi by 6, that is approximately 21 by 2 into 5 by 6 into pi value is 22 by 7. After simplifying this, we get the distance covered by the horse is 27.5 feet. Next problem, a wire of length 20 cm is bent so as to form an arc of a circle of radius 12 cm. What is the angle of the center? Angle at the center. So see here, given the length of the arc here, it is given. The wire of length 20 cm is bent so as to form an arc of a circle of radius 12 cm. So length of the arc S is equal to 20 cm is given, and also the radius is equal to 12 cm is given here. So theta, we have to find out here theta. So theta, S is equal to R theta means theta is equal to S by R. So S is 20 by 12, that is 5 by 3 radians. The question number 3, a circular metallic wire of radius 3 cm is reshaped into a circular arc of radius 48 centimeter. Find the angle subtended by this arc at the center of the circle. See here, S is equal to circumference of the circle of radius 3 centimeter. S is what? Length of the arc, but it is a complete arc, whole circle. Therefore, circumference we consider, that is 3 centimeter. Radius is 3 centimeter is equal to 2 pi into r. This is the circumference of the circle. Formula 2 pi into r. R is 3. Substitute here 2 pi into 3. That is 6 pi centimeter. Now, what is the radius? Radius of the next circle be, the second circle be 48 centimeter. Therefore, again same formula we can use. S is equal to r theta. We want the angle at the center. That is theta is equal to s by r. S is 6 pi. Substitute, and the radius is 48. 6 ones are 6 8s are 48. That is pi by 8 radian, or approximately 22.5 degree angle at the center.